Hey peeps, we'll make this really quick. So after your activity with the energy skate park, you should learn some things about energy. And we'll talk about this law of conservation of energy. Law of conservation of energy says that energy can't be created or destroyed. It can only be transferred from one form to another. And we can keep track of different types of energy like kinetic energy, potential energy, and in some cases things like friction and heat. Okay? But the law of conservation of energy really is telling us that the total energy before something happens is equal to the total energy after something happens. You can think of it like throwing a ball up into the air, or like that skater in the skate park. But with this ball, if I throw it up in the air, it might start off with a little bit of potential energy down here, and a lot of kinetic energy because it's going really fast. But as it goes up, that potential energy, because it's gaining height, actually increases. So it gets a little bit bigger. But the kinetic energy decreases because it's getting smaller, or it's going slower. When it gets up to the top of its path, we say that all the energy is potential energy, and it would have no kinetic energy because at the very top of its path, its velocity is zero. So the forms of energy are just really switching from having a large amount of kinetic energy to smaller to none, and the amount of potential energy is increasing. On the way down, it's just the opposite. The potential energy will end up decreasing because it's closer to the ground, the height is less, but the kinetic energy would increase because it's getting faster. There's other ways that we can represent this, and that's just kind of like on these, but in essence, our total energy between kinetic and potential energy in any situation has to equal the total kinetic and potential energy in any other point along the path of an object, and that's being kind of affected by gravity. So kind of like in this example, if someone was biking and they were gaining speed to go up a ramp and then over the edge, down here at the bottom, we would say that this person's potential energy would be zero if they were right here. And kinetic energy would be like 500 joules. Maybe they were biking along, but their potential energy down here at the bottom would be zero because there's no height. As they go up, the potential energy, kinetic energy would end up changing. So the potential energy, they would have all potential energy up here at the top. They weren't really moving very much. They would have a kinetic energy of zero. And then on the way back down, potential energy would drop again, but the kinetic energy would increase because now they're going faster. But the entire time, when we look at each scenario, this case, their energies add up to 500. This case, they add up to 500. This case, they add up to 500. They will always add up to the same number each time throughout that path if gravity is the only thing really affecting it. So there's kind of this case with a person that is being rescued by some firemen and firewomen down below, and they jumped out of this window and they're gonna get caught in this little trampoline thing. And so good thing that the firemen are there, but also a good thing that someone was keeping track of their potential and kinetic energy. They must have thought it was time to do some physics. But on the way down, if we know the potential and kinetic energy at one point, the total amount, they started from rest up here, so their kinetic energy is zero, but they were starting from a large height. Maybe they have a potential energy of 10,000 joules. I can actually figure out some of the potential and kinetic energies on the way down, but if I'm missing something, I can also figure those pieces out. Like in this case, the potential energy they say is 7,500, but they didn't tell what the kinetic energy is. But that's actually not too bad because I know that if the total kinetic energy at the top here is 10,000, then the total energy down here also needs to be 10,000. In fact, it's going to add up to 10,000 the whole way down. So if I know that this is 7,500, it's 7,500. If I subtract that from 10,000, I can figure that out. What that kinetic energy is. And it's 2,500. And remember the unit for energy, it's joules. So we just abbreviate with a J. And your job is going to be figuring out what the missing energies are for the other parts. That's part of your assignment. You will also look at another example like this one with a pendulum that's swinging from one side to another. And think of it like a big ball that was maybe your friend was holding over here and they were swinging it over here kind of like a wrecking ball. But if they tell me potential energy's kinetic energy is at one point, I could figure out potential energy and kinetic energies at any other point in this problem. Like here's a kinetic energy that's missing. But can I note that they gave us this information here. And I'm going to actually solve out this one. And so if I want to know what the kinetic energy was here, I could really compare it to what I really started with. Together, my total energy was 10. By conservation of energy, the total energy does not change. So these have to add up to 10. My potential energy is 0 because it's at its lowest point, the height is 0. It means the kinetic energy must be 10 for these to add up to 10. That's kind of it. And so, but your job is going to be figuring out what's the missing energy here. And then this one, no lie, this one's just the little tricky one, but I want you to figure out the missing energies in this diagram. And so the rest of the time is yours. You guys will do great. Have a wonderful day. But key takeaways are conservation of energy, total energy of a system, it will remain the same. So if your total energy here is 10, total energy over here is going to be 10. And everywhere else, it will be 10. All right. See you guys.